For the program, we let the AV3 show the distance that the ultrasonic sensor sends on the screen. And also, when the distance comes to 5, 10, and 15, etc., the red light lights up. So the person moving the robot, which is the measurer, will be able to know easily that the robot is at the distance we need. The other person then record the data from the computer, which also shows the distance and the value of brightness. You can see that in the video. Okay, so this is our roles. I'm Ian, and I'm the builder and the measurer. Elwin is a programmer, and he's also responsible for documenting. Okay, so this is our setup for the experiment. There is of course the main part of this experiment, the light sensor. And beneath that, we have an ultrasonic sensor. We use it to measure the distance between the light source, which is the phone, and the light sensor.
Basically, we use ultrasonic sensor to know the distance. We also use the program to change the color of the light in every 10 cm to make our data more accurate. This is our variable. In this experiment, our independent variable is distance, and dependent variable is brightness, and control variable is the same device, programs, and environment. In this graph, we can see this is an exponential decay, which means the distance and the brightness have inverse proportion. We use the average to make this graph. The graph of standard deviation shows how accurate our experiment is. We can see that there are still many data that are not accurate in our experiment. This is the chart for standard deviation. In our conclusion, when the robot moves farther from the light source, the brightness will decrease. However, we should fix some control variable to make the experiment more accurate.
For our reflection after experiment, we think there are a few things that we can improve. First of all, the data may be inaccurate because of the light from the environment. We should either find a way to keep it all dark or just put it in a light room so that all experiments have the same condition. Second, the angle between the robot and the light source may also affect the accuracy. To improve that, we can add motors and wheels to the robot and let it move by itself. This way it is easier to keep it at a constant angle toward the light.